Okay, today we'll discuss the power system analysis, transmission line, steady state operations. And we already discussed the objectives of this chapter, which is chapter 5, the last time. And just to go again here, we want to relate the ABCD. We already discussed the ABCD. We call it ABCD parameters. By the way, if you want to do to pursue your graduate studies, to continue your master, this is one of the fundamental, this chapter, one of the fundamental topics that you will be asked to solve. So if you want to go for a master degree, a PhD degree, the ABCD parameters. How to find A, how to find B, and so on. Okay. Okay, so we discussed also to relate them actually. VS, for example, will be VR, A times VR plus B IR. You see, we are multiplying this way, row by column, row by column. So A VR plus B IR. What about IS? C VR plus D IR. So we want to find these ABCD parameters. We call them ABCD parameters. These A, B, C, and D are parameters that relate the sending end with the receiving end voltage and currents. Now, if we have a short transmission line, for example, a short transmission line will be less than 25 kilometers in length. We can represent the transmission line like this: a resistance and inductance. So this is a reactance. So this is an impedance, series impedance. So we can represent the transmission line. If you're asked to present the transmission line, you will just write the Z, R, and X. So what about Y? We neglect Y. Okay, so this is, we call it a short transmission line representation. Now VS, we can then relate VS with VR, sending end with the receiving end. How do we relate them? We relate them in this way, actually. This we have Z, therefore VS equals what? Equals VR plus I times Z. Now Kirchhoff voltage law, KVL. VS equals IR, I times Z, and then plus VR. This is KVL. So we're doing KVL here. So VR plus IR times Z. This is the VS. So what about IS and IR, the relationship? This is, there is no branch in this circuit here. IS equals IR. Therefore, here, as you can see, IS equals IR. IS equals 0 VR plus 1 IR. Therefore, IS equals IR. The sending end current equals the receiving end current. Therefore, we can put the ABCD parameter this way. A is 1, B is Z, C is 0, and D is 1. Okay, so A, B, C, D. This is the way we write them. Okay, so that's it. So A equals D in the short transmission line. B equals Z. B equals Z. C equals 0. Okay, so this is for a short transmission line. We can represent it this way. For a medium transmission line, this is between 25 to 250 kilometers, as indicated in your textbook. We can represent as a pi circuit. Pi circuit means that we have a branch here, which is y over 2, and this is y over 2. So we have in both ends, we divide y into both ends, y over 2 on one side, and the impedance of the transmission line is in series here as of the transmission line. So we have the impedance and we have the admittance on both sides. So this is a medium transmission line. So it's called nominal pi circuit. Later we will have equivalent pi circuits. So this is pi circuit, okay, pi circuit, because it looks like pi, the shape. So what's the difference between short transmission line and medium transmission line? يا فهد غالب عبد المجيد. تفضل يا فهد. Not here. تفضل يا أنور هشام. أنور هاشم. Not here. تفضل يا عمر. No, not Muhammad. I asked for Amr. تفضل يا أحمد شهاب.
Yes, doctor, are you hearing me?
No, no. أحمد شهاب.
I'm Amro, doctor.
طيب. تفضل يا عمر. What's my question? طيب. تفضل يا أحمد هشام. What's my question? Okay. تفضل يا أحمد علي الرياحي. تفضل يا آدم. Okay. عبد الله الجابري is here or not here? Okay. عبد العزيز يوسف شعبان. عجيب. عبد العزيز اليهري. Not here. Not here. عبد العزيز الإبراهيم. If you are here, you can write. Please don't complain then for your mic. Okay. If you are here, you just write. You are here. Okay. Say yes. Say something there. Okay, on the chat. Okay. So you should not complain about your mic. That your mic is not working. Okay. Abdulaziz Al Ibrahim. Say just yes if you are here. Abdulaziz Bouhazza. Thank you, Abdulaziz. Okay, Abdulaziz, we're talking about the transmission line, the medium transmission line, and the short transmission line. So what's the difference between short transmission line and medium transmission line, Abdulaziz? What's the difference? What's the difference? This is too late, Ahmed Riyah. What's the difference? Abdulaziz. Okay. You don't know the difference between short transmission line and long transmission line. So the difference is simply that we have. No, we don't want you to open the mic. We asked you to write. You see, you're trying to open the mic. You are there and here. You're not, okay, so it doesn't matter. You are not close to the computer. Your computer is open, yes, but you are not close to the computer. Okay, I'm trying to open the mic. You don't need to open the mic. Just write. You can just write a comment. Ya Ahmed Al-Riyahi. So tell me, Ahmed Al-Riyahi. Okay, so this time I will take you from here. Okay. تفضل يا أحمد الرياحي. أحمد الرياحي, not محمد مرتضى. Okay. تفضل يا أحمد الرياحي. What is the difference between the short transmission line and the long transmission, the short and the medium? What's the difference? Different parameters? Okay, different parameters. Okay, so it's a different structure. So the short transmission line will look like this, as you can see. Okay, Z, but we don't have the branch. And then the medium transmission line, we added the branches here for the medium transmission line. Remember now, these are how we represent the transmission line, how we write the transmission, how we put the transmission line into a circuit. Okay, so how we represent the transmission line. Represent the transmission line by a circuit. The circuit could be just Z, the impedance, or if it's a medium transmission line, then we can add the branches here. When we say medium or short or long transmission line, as we will see later, the long transmission line, that means we are going close to what? To exact. So if you want to maybe 1 or 2% is insignificant, that will be maybe short transmission line. If you want exact, then we need to include the branches here, the admittance. We need to include. We want more exact, even if it is 20 kilometer, for example, and you want to represent the transmission line, you can include this branch y/2. Okay. So we need to give you y/2, or from the characteristic of the transmission line. Okay. So here is also the same thing. Here we want to relate the KVL, the sending end with the receiving end. Then we can relate them this way here. Okay, Vs equals Vr plus Z times this one. This is KVL. Okay, KVL. So we can relate Vs equals this. This is the equation of the V sending and V receiving. So the idea here, we want V sending on one end, V receiving and I receiving on the other end. Similar for the I sending also. Sending, so this will be related to R, which is the receiving end, and the sending end. Can relate them this way. Therefore, at the transmission line, we can write it, then the A, B, C, D can be written this way. Okay, so B will be just simply Z. A equals D. This is always now in the short transmission line and medium transmission line, A equals D. Okay, so A equals D. B and C are not equal, of course. And the relationship will be simply like this. Now, we can use these also, by the way, A, B, C, D, with the short transmission line. If we represent the short transmission line, if we have the admittance of the short transmission line, then we can represent it like this. Okay, so it will give us what? More accuracy. Okay, more accuracy, but it's insignificant. At the end, you will maybe find it maybe 0.1% or so if you're talking about short transmission line and medium transmission line. So maybe 1% or so. Okay. Okay. Now, the ABCD parameters of common networks. If we have a network like this is a short transmission line, we can represent it this way. A, B, C, D. So what do we need to remember from this one here? You need to remember these three. 1, 2, 3. Okay, these three. You don't need to memorize these two. In the final exam, by the way, you will be given a cheat sheet, not a cheat sheet. We will talk about the final exam later. But how to study here, you will be given short questions with no cheat sheet. And then you will be given problem to solve. Then we give you a formula sheet, or I will ask you to bring your cheat sheet. So the final exam will be two parts. Two parts. You submit the first part, that it is a closed book, no cheat sheet. That's the closed part, the first part. After you submit the first part, then you will get the second part of the exam. Talking about the same class now, 2 hours you will do in the final exam. One, you need to know, so that is will be closed book. So it's like an interview questions, short questions. And one is problem solving, so you need to solve the problem. This problem solving, you can use your formula sheet, or I will give you the formula sheet. We will see later whether I give you a formula sheet or you will use your own formula sheet. Okay, but in the first part of the final exam, there are two parts. First part, there will be no cheat sheet or formula sheet to do. So you need to understand the topics. That's what we discuss here. Okay, so you will not write then everything. So, okay. Yes, Muhammad Murtaza. Fadl.
Yes, doctor. Doctor, the fourth circuit, the pi one, we did that previously, right? Like just now, or
What
it's
is it?
different.
What did you do? What?
The fourth circuit,
What
the fourth pi circuit. We discussed it just now, right? Or it's
this
a
one?
bit different.
Yes, yes.
Yes.
No, no, this is the same. Yes, the
Okay.
same. That's what we discussed. Yes, you're right. So, okay, so that is the fourth one. So this is the circuit. If it comes like this, then we will have it like this one. So this is a common networks, how to relate A, B, C, D parameters. Okay. What you need maybe to know here is that A equals B, A equals D. But if we have if y1 equals y2, if y1 equals y2, therefore A equals D. If they are not, you're just simply, this will be y2, this will be y1. Okay, so this is y plus yz. So what you need to remember, I will tell you now, to remember this one, and this one. You need to remember three of these. Okay. This one you don't need to remember. If we give you a circuit like this, you will be given the ABCD parameters. Or like this, you will be given the ABCD parameter. This, what does it mean here? Series networks, if we have the same network that is repeated itself, then we can do this. We multiply ABCD parameters. A1, B1, C1. Okay. So if we have another circuit here, for example, the same circuit like this one, and this is also connected to the same circuit. Okay, circuit and then another circuit connected together. This is what we mean by series networks. A network and another network. So we have a sending end, receiving end, and then another sending end, receiving end. Okay, with the same. Okay, same what? Same. The receiving end on the first circuit will be the sending end for the second circuit, and so on. So we can do it this way. But do we need to remember this? No, you will not. You don't need to memorize this part here. But you need to know these. You need to know exactly how to represent the circuit, the ABCD parameters. Again, of this one, and this one. Okay, so this is the short transmission line. This is the medium transmission line, but represented as Y in the middle. This is represented as Y1, Y2 on both. So Y over 2, Y over 2. Okay, because Y1, Y2. So we can represent this Y here into two parts, one there, one in one end, one on the other end. But this part here, by the way, it have Z1, Z2, another circuit. And anyhow, again, now just what I would like you to do or to remember. I don't need to say memorize. this one, this one. These are two parameters that we discussed. The short, maybe two. Okay. So the medium transmission line, the short transmission line, and this one here also. This one. Why? Because now VS, because this is simple now. See, VS from here to here is the same as VR. Why? Because also VR is from here to here. Therefore, the A will be 1 and the B will be 0 because VS equals VR. Remember now, this will be 1 and this will be 0. Therefore, VS equals A times VR plus 0 IR. معناها VS equals VR. Okay, so this is simple. I will be different now. If you want to find I, it will be different. In this case here, I is the same. What case now? Talking about this. IS equals IR. So this will be 0 and this will be 1. C will be 0, D will be 1. Why? Because IS equals IR. Here IS does not equal IR because we have the branch. So this is why we have Y here and we have 1 here. So C will be Y. All right. So again, just the last thing that to remember, I would like you to know these three. 1, 2, 3. Okay. You will be given a circuit, how to write the ABCD. Okay. From these three. So you can relate them by Kirchhoff voltage law and Kirchhoff current law. These are just circuits. Another thing that ABCD parameters advantages why we need to also to have the voltage regulation. ABCD can be used to describe the variation of line voltage with the line loading. What is voltage regulation? Voltage regulation simply is the voltage, the receiving end voltage. Now we talk about the receiving end voltage, voltage regulation. This is percent voltage regulation called VR. The no load at the receiving end minus the full load also at the receiving end over the full load. So if the no load here is higher than full load, then the percent voltage regulation will have a value. The no load is higher than the full load. If they are equal, no load equals full load, then the percent voltage regulation will be 0. Okay. So the voltage regulation is the change in voltage at the receiving end of the line when the load varies from no load to a specified load. Remember now why we use this voltage regulation, because you need the percentage to be within limits, maybe 5%, 4%. The change, how much change you want it from 1 per unit to what, 2.95, from 1 per unit to 1.5, 1.05 or 2.95. For example, you want this one. So how you work on these? You will calculate the voltage. I'm talking about now in reality. What do they do? And then you want, for example, they want to add, for example, a shopping center or an industry there. They need to calculate the voltage. So they will assume that this is a full load now shopping center. And they will see what is the variation of the voltage. If the variation is high, then they need to support the bus by compensation, by another transmission line, by not giving the load. So they will just maybe reject to have an industry, for example, or factory to be installed there, or a shopping center, or any heavy load, for example. So the full load, so this will tell you, actually the voltage regulation will tell you how far if you increase the load, how far you will go from the no load. Okay. So this is voltage regulation. So you want the voltage regulation to be within limits, short limits, maybe 5%, plus minus 5%. But then huge, then you need to do some measures there. So you need to correct things there. As an engineer, you need to correct. That's what you do. That's what you study, the system. Okay. That is in the planning section, that when they do planning, you need to study the voltage regulations. Okay, now relating actually the phasor diagram, for example, you have VS and VR. Remember now, this is a short transmission line because there is no shunt. So this is a short transmission line. Now, if the power factor is lagging, so you can draw VR full load here. You start with VR full load. And then it's lagging or leading. They will say lagging, therefore you will draw the current lagging the voltage. Talking about now receiving in the current lagging the voltage. And then that's it. So you will be given VR full load and the current, is it lagging or leading? That's it. That's the whole information. Then you construct the phasor diagram. How we construct the phasor diagram? We start with this current, small current here. It is parallel to this current. This is IR. This is the I times R. I full load times R, which is the real part of the impedance, this part. And it should be parallel with this current, so it's parallel. And then X, and we always mention that X is always higher than R in the transmission line. Okay. So X is higher, the same current because the same current actually which flows on R will flow also on X. Same current times X. X is higher. And it should be at 90 degrees from here to there. 90 degrees. Okay, well, I need to do this. 90 degrees. Here will be 90 degrees. 90. Okay. So this the angle is 90 degrees. Of what 90 degrees? 90 degrees of this current here. IX, IR. Okay, so IX is 90 degrees, then IR, over IR. Because of this J here. JX IR. So this is RIF. So this is the real part, and this is the imaginary part. And this is the real part. 90 degrees. Then you will draw 90 degrees and you will make it longer than this part here. This is a voltage. This is a voltage. Voltage of what? Voltage on here. This one. The voltage on the R. I times R. And then this also the voltage. Voltage drop, of course, on X. Then this is the voltage drop on X. This is the length. So the voltage drop on X is higher than the voltage drop on R. Why? Because X is greater than R. How do we know? This is a transmission line. We don't write the numbers here. But as an engineer, you need common sense. Okay? So you are familiar now, X is higher than R. So if you see, when you read the data there, you can tell this is the data is wrong, has some problems there. Maybe the data entry man, for example, enter maybe a wrong number, maybe wrote maybe 0.1 per unit for R and 0.01 for X. Cannot be like this. So then you can determine this is there's something wrong on the data. This is what engineers do actually when they work on the planning or the calculation. That's what they do. All right. After you draw IX, IR, and IX, then the summation will be VS. Therefore, you will draw VS, the summation. So you will go with this line here. You see now VS is higher than VR, the no load now. This is the no load. When you come to this is a leading power factor, a leading power factor. So what you will start? You will start, of course, with VR full load, same length of this. All right. And then you will draw the current. This is the second part here. You will draw this, the current, leading the voltage. So you will draw the current with an angle here. This is an angle up. And then that's it. So that's what you will draw. Lagging power factor, leading power factor, VRFL with the leading power factor. And then you will draw, this is parallel again to this one. Okay. To R full load, parallel. And then 90 degree here. You will do like this. Okay. You will do the you will draw the GIX 90 degree. You see now this comes in here. Therefore, VS will be here, which is VR no load. VS equals VR no load. How do we know? Because there is no current here. At no load, there is no current flow. So VS equals VR no load. Similar to this one, VS equals VR no load, but this is V full load. Okay, VS equals VR no load. Why? Because there's no current here. So the voltage, you measure the voltage on the VS with the same as VR. So you write VS. You see now VR no load. Now the receiving end no load is lower than R full load, or maybe the same. Okay, maybe the same or lower the magnitude. So VR full load, and because of the leading power factor. Because of the leading power factor. Here, because of the lagging power factor, VS, you need more pressure. You need more voltage on the sending end for a lagging power factor. Lagging power factor. Okay. So for a leading power factor, this will be the drawing here, leading power factor. Okay, any question here? Lagging and leading. You already may be familiar in the machines. You had this.
Doctor?
Yes.
So we prefer a leading power factor over a lagging power factor?
No, we do not prefer leading power factor. We prefer to be 0.99 lagging. Okay. A leading power factor means that the generation is absorbing reactive power. We don't want the generation to absorb reactive power. So, but it's unity, that will be okay. But 0.99, 0.98 is good. So we don't prefer leading power factor, but we prefer one per unit. That is unity power factor. That will be okay. We still now, in case, okay. So that's maybe the idea. Okay. But leading, too much lagging is not good. Okay. So 0.87 maybe is operating. It's allowed. If the factory or the company exceeds, if they have low power factor exceeds the limit of what? Of 0.87, for example. They're given a power factor of 0.7. If they exceed, they pay penalty to Kahraman. Okay, they pay money because their power factor is low. So every factory, industry needs to correct their power factor on their own. So what they install capacitors, okay, to improve the power factor in their company there. Okay, because they measure the power factor and then they will pay penalty. Okay, so they bring it up to 0.9, 0.87 will work okay, but below that they need to pay penalty. All right. ABCD parameters and the nominal pi circuit. Because we say nominal, خليكم كده حلوين. Nominal means that we are using this, then we have another equivalent, okay? Nominal pi circuit, we are using this one here, Y on one side and Y2 on the other side. Okay, this is called nominal pi circuit. This is pi circuit. Okay, so the terminology, what you read here, so you will be familiar with this one. A three-phase, okay, three-phase, completely transposed, so you're already familiar now, means that every phase will carry the same current. Okay, will carry the same current. So completely transposed means balanced. Okay, so another word is balanced. 345 kV means this is the rating of the transmission line, the rating. Okay, 200 kilometer, of course, is the length of the transmission line. Has 2795 kc mil, kilo circular mil, and given also the ACSR. So this is table A4. So you will go to table A4 per bundle. So means 2 per bundle. And the following positive sequence constants. So we have Z and Y. Okay. Again, now when you are given these, yes, I will be given ohm per kilometer. These are given. Siemens per kilometer, ohm per kilometer. And we write here on this now, خلاص كبرنا الحين. We write here small z, small y, not capital. Why? Because this is per unit length. Because we want to differentiate between per unit length and the total z that we represented on the transmission line. So this is per unit length. And this is come from the sheet or from the manual. Okay, so we given per unit length. And then how long is the transmission line we have, then we'll just multiply by how many, the length of the transmission line. Okay. Full load at the receiving end of the line is 700 megawatts at 0.99 leading. At 95% of the rated voltage means that this voltage here, you need to multiply it by 0.95 because it is operating at this. So the receiving end is operating at 95% of the rating voltage. Okay, so you multiply 0.95, which is 95%, times the rating voltage. So this is the receiving end voltage. And what is the load? This is the load power, real power. And this is the reactive power. This is the power factor leading. Therefore, you can determine the reactive power. And the reactive power will be negative. Why will be negative? Because this is the load. And the load now is injecting reactive power into the system. How do we know? Because it's a leading power factor. So the load is injecting reactive power into the system. It's a leading power factor. So this will be P minus JQ, not P plus JQ, P minus JQ. So the reactive power, if you're asked to find the reactive power, then you can determine it is minus JQ. So the load does not absorb reactive power. The load injects reactive power, or the load delivers reactive power. But always the load absorbs real power. The load will never give real power, will always absorb real power. So this is positive always, P. Unless it becomes generation, then it will deliver reactive power. Will deliver active power or real power. Okay, so we want to find ABCD. Assuming a medium length line, before we go, I see the medium length line, determine the following. Medium length line, so you know now it's a pi circuit. So therefore you need to determine as a pi circuit. We want to find A, B, C, D, and then the sending in voltage, all the rest now comes. Percent voltage regulation, so we know the percent voltage regulation, V receiving, V at no load minus V full load, etc. Okay, over V full load. And then the thermal limit, because every transmission line has a thermal limit. The Qatar power system, you will find that they operate at 50%, 60%, okay, They don't operate at the maximum limit. They operate at 50%, 60%. Okay. But anyhow, there is a thermal limit, of course, of the transmission line. How do we know this? We'll go to table A4, our favorite table, A3 and A4. Okay. So approximate current carrying capacity. So this will be the thermal limit is based on the current. Okay, the thermal limit will be based on the current. So okay, so please don't write on the slide. And the transmission line efficiency at full load. All right, so let us look at these now. The ABCD parameter is simply what we need to do. We need to use this ABCD. This is from the ABCD, from the circuit, okay, from the pi circuit. So therefore, before we go in there, you need to multiply by the length before you do this calculation, and then you will put here. So what do we want? We want ABCD. So this will be A, just 1 plus Y times Z, and this will be B, this will be C, okay, and this will be D, and A equals D. So you calculate only one time, A, and this A equals D. So this is D. See now how easy is this? Just find Z and Y. You see now how easy is this chapter? Just find Z and Y, capital Z and capital Y. This is not per unit length. This is Siemens or ohm. And then you find these values. These fixed for medium length line. Okay. So just find these. Just calculate them. So you need a calculator that has what? Has to work with the complex numbers. Z is a complex number. Y is a complex number. Okay, so you need a calculator to work with a complex number. Okay, so that's what you will do in the final exam. You will have, you will use your calculator. So try to make sure that your calculator is working with a complex number, not a simple calculator. Okay, so then just you will have find A, B, C, D parameters. Easy. This is very straightforward. And then what we want to find the sending end voltage and the receiving end the sending end voltage. We already know the receiving end voltage. How do we know? We know this 0.95 times this. This is the receiving end voltage. Okay, 0.95 times 345. Now, is this line to line or line to neutral? Who will tell me now? تفضل يا سعد فهد النعيمي. If you are here but you cannot open the mic, تفضل يا سعد. No, I asked for سعد. Not here. تفضل يا تميم.
Yes, sir, I'm here.
تفضل يا تميم.
I think this is a line voltage.
This is what?
Line to neutral.
Line to neutral.
This is, I guess.
يا حبايبي يا حلوين. يعني we always mention this. Okay, this terminology is very important for you as an engineer. When we mention about three phase, when we mention about three phase, and you're given a voltage, this will always be line to line. So we'll not tell you this is line to line or line to neutral. This will always be line to line, like this. Given three phase, unless we indicate it's line to neutral. If it's just given like this, three phase, 60 hertz, completely transposed, 345 kV, that's it. So it's line to line. Okay. All right. Otherwise, if we give you this line to neutral, then it will be line to neutral. Okay. But we usually give it this way. So please do not ask if it's line to line or line to neutral. You should know this is line to line. Because we mentioned here it's a three phase line. Okay, we'll not mention line to line. All right. Okay, so it's line to line. So what you will do here, we want to find, so we find that A, B, C, D parameters with this is given, as you can see here, straightforward. So we, after we find A, B, C, D parameters, just simply by using these, by the way, just simply these. So you already know, just find Y and Z and that's it. You see, it's given, actually. So what is I am actually testing you on this one is how to use actually your calculator and when working with complex numbers. This is the whole thing. So if you please don't make mistakes in calculation of the complex number. Otherwise, because this is given now. So you already know this. So you already know Y and Z. So just calculation now. This comes to calculation. So this is where I test you whether you work in complex numbers or not. That's for the ABCD. And then what we want to find, we want to solve the receiving end. Of course, the receiving end is given 345 because it's in a 0.95 operating at 0.95, then it comes via line to line, of course. You want line to neutral, just divide by square root of 3. And this will give you a value of line to neutral. You put this is 0 here, so we started from here. So this is our reference. So any angle now comes, you are comparing it with this, the receiving end. You can put as a reference here. Why we put this as a reference? Because we worked with this now. So we know now the voltage. Okay, so we know the voltage. So we are working on this one. So this is our reference. So we made this our reference. So put 0. So please don't ask how do we get the 0. This is our reference. Okay, although it did not mention anything about that a 0 degree, but you put this one as a 0 degree, and okay. All right, and then we have the P, the power. Now, what's this? This is actually P plus JQ. That's why I put cosine inverse. So this is an angle here. Okay, the power and an angle. Cosine inverse 0.995, and this is the voltage, the square root of 3 times 0.99. So this is the power factor. So then you can find IR, the receiving end. This receiving end is for 3-phase or for single phase? The 1.246 kilo ampere. Single phase or 3-phase? Ya Zaid Samir. Ya Zaid bin Samir. Not here. Not here. عجيب. يوسف أحمد حسين الشيخ. عجيب. عندكم امتحان اليوم ولا شنو؟ أسامة عتيق. أسامة عتيق. تفضل يا أسامة. This is 3-phase or single phase. Okay, so because now I would like the rest now to please register for attendance. Although I took your attendance now, but I need to take your attendance now by name. Okay. حسام خالد العارضة.
Yes, here.
Yes, here. Okay. We said Khalil Khalid. بسرعة يا شاكر because I need to close this. Khalil, not here. All right, Leith. Okay, here. محمد الحريري. Yes, Leith. I know. محمد فهد.
Yes, doctor, I am here.
محمد الطيب. What's it? Cannot see. يعني you already discussed this. محمد الطيب. I said محمد الطيب. Why you not say yes? محمد الطيب. It's not here. محمد هاني. بسرعة. محمد هاني. مين محمد؟ محمد الفقي ولا محمد الطيب؟ Yes, here محمد الطيب. محمد الطيب. Okay. محمد الطيب. ومحمد هاني. ومحمد خالد.
Yes, doctor.
محمد جاد. ومحمد طاهر. محمد ماهر. محمد طه. محمد مرتضى.
Yes, I'm here, Muhammad Murtada.
محمد مرتضى here. Okay. محمد سامي.
Yes.
محمد إبراهيم فخره. محمد محمود حسن.
Yes, دكتور.
Who's yes? محمد هو.
محمد حسن.
Okay. محمد ناهض نايف. نبيل بن عمار just joined. عمر طارق.
Yes, doctor. Yes.
خلاص. Okay. Alright. ما شاء الله. ايش عندكم امتحان اليوم؟ Okay. Let me now just stop